Okay, YouTube, in this video I'm going to explore the concept of radian measurement in order to measure an angle. And so what we're going to start with is this, the fact that angles can also be measured in radians. So we've seen angles be measured in degrees before. That is to say that, we have these angles starting in the positive x-axis going around one full time, say that's 360 degrees. So when we talk about radian measurement, we're going to start by defining what we mean by what that is. And so what we have to imagine is a circle centered at the origin here. And you can see that we have this 1 radian measurement illustrated here. And so let's go ahead and start by talking about what we mean by, well then what is 1 radian? The idea is that when you have a circle centered at the origin, no matter what circle you have here, this circle has a radius length. And so we can see that this angle formed here is what we call a central angle, since it starts in the middle of this circle. But we'd see that it goes out and it casts an angle here, right here in the middle. Let's say this is the thing we're trying to measure. Well, the idea is that the bigger and bigger this angle gets, the more and more this rotates here, that the longer and longer the intercepted arc is along the outside. And so we say that this intercepted arc, we can imagine that every angle, that if it's inside of a circle like this, has an intercepted arc. And so the idea here is this. We can tell you how big this angle theta is here if you can tell me how many times the radius length fits into the intercepted arc. That is to say, how many times it divides into it. And so when you see that theta is 1 radian here, we say theta is 1 radian. We often write it as theta is 1 radian, or we just say theta is 1. And what this is really telling us is your angle is so big that the radius of the circle, this distance here, or maybe this distance here, fits into this distance of the intercepted arc 1 time. So that is to say that's, congruent with that is congruent with this. And so if the intercepted arc is the same length as the radius, then we're talking about 1 radian worth of measurement here. If I were to double this angle, go a little bit further here, we'd say go this and then rotate another radian here, 1 rad is in the way we write this here, then we would say that the radius length, we've gone another radius length around the outside. And so this original angle here would be 2 radians, but because the radius length fits into its intercepted arc twice. Now, we don't always have to fit in exactly 1 or exactly 2 or 3 or however many radians, but you certainly see that a lot of the time that happens if you're talking about convenient situations. We could have 1.57 radians, that's perfectly fine. It just means that your angle is so big that the radius fits into the intercepted arc 1.5-ish times, okay? So what we're going to do is confront in this video, how do radians compare with degrees? And that's kind of a big issue here. We're going to talk about some common radian measurements. But basically, let's go ahead and start with this. How many radians are in a full 360-degree spin? And so we'd say the definition of a radian, definition of an angle in radians. Let's go ahead and define this here. The definition of an angle in radians, we say, is that angle is equal to however many times the radius fits into the intercepted arc length. So we'd say the radius length, how many times does it go into the intercepted arc length? And the neat thing here is this. We would say, well, 360 degrees, that's kind of 1 full rotation here. So how many times would, given any circle of radius r, how many times would that fit into the outside? And so because we know the circumference is equal to 2 pi r on a circle, then really we could say the number of radians for 360 degrees, just a little subscript I'm going to write here, is equal to the circumference here, circumference, however many times the radius fits into that. And so what we're going to do here is we're going to take 2 pi r, we're going to divide by the radius here, and we can easily see that the radius is going to divide out. But basically what this means is 360 degrees is the same thing as 2 pi or 2 pi radians. We don't ever have to write radians. If you say that an angle is a real number and not with a degree symbol, then we assume you mean radians. So here's the important thing, is that we can go ahead and start to tie together some pretty standard angles. And those, starting with these, are these. We'd say 360 degrees, and we're going to say this is in degrees on the left. We'll write our radian measurements, equivalent radian measurements on the right, radians. And we'd say that 360 degrees is the same thing as 2 pi radians. So if we split this in half, these are kind of some important measurements here. We'd say, well, then 180 is half of 360. Well, half of 2 pi is just pi. So 180 degree angle, that's the same thing as pi radians. And so because these two are the same thing here, I could go in half again here. We're going to look at these. We're going to say 90 degrees, which is half of 180, would be half of pi. So we say that that's exactly pi halves. And we just write it as pi halves. But you can see that this right here is a very, very convenient measurement that always compares degrees to radians. And so we're going to use this as what we call our conversion factor here. And we're going to say that these are conversion factors. Essentially, as we get used to radians, we'll see them more and more, and we'll get used to what they mean. And we're going to finish kind of supplementing this list here, but for right now, just know that we can convert them back to degrees if we need to. And what we're going to do is we're going to use this comparison that pi radians is the same as 180 degrees. And so to go from degrees to radians or radians to degrees, we'll talk about the order in which you multiply here. In either instance, though, you see we're going to multiply by either pi radians over 180 degrees or 180 degrees over pi radians. But those mean the same thing. So to continue forward here, let me go ahead and scroll down here. We say 90 degrees is the same thing as a pi halves measurement here. If we go half of a 90, this is another very common measurement. Half of a 90 is a 45-degree angle, and half of a pi halves would be a pi fourth. Sorry about the switch in color here. And then I'll go ahead and put these last two, I'll try to squeeze them in down here. We say 30 degrees. Now the interesting thing with 30 is 30 degrees is 1/6 of 180 degrees. And so we would say 1/6 of pi, or 180 degrees is pi radians, we'll go 1/6 of that rotation. And then we'd say a 60-degree angle, which is 1/3 of a 180-degree rotation. That must be 1/3 of a pi radian rotation there. And so these are common measurements that we see a lot of the time. What we're going to do in this video is we're basically wanting to become proficient at converting from, say, radians to degrees or degrees to radians. So let's go ahead and start with this. We would say convert the degree measure to radians or radian measure to degrees. And so with this negative 150 degrees, let's go ahead and take a look at this kind of our cheat sheet down here. But it says we want to go from degrees to radians. And so what we're going to do is we're going to multiply this 150 degrees, it's negative, by pi radians over 180 degrees. And so what I'm going to write here is essentially this. This is a negative 150 degree measurement. I'm going to put this over 1. And what I'm going to say is that we're going to multiply this, of course, by what this says down here, which is pi. And I'm going to write the word rad here, or radians, over 180 degrees because they mean the same thing. But what I want you to see is that when we multiply by these units or these degrees, they cancel out. And so now when we say, well, I guess we could continue to reduce this, 150 and 180 here. 30 goes into both of those. 30 goes into 180 6 times, and 30 goes into 150 5 times. We get a negative 5 here. But eventually we end up with irreducible terms. So we get negative 5 times pi on top, so we get 5 pi, and it's definitely negative. And this is over 1 times 6 on the bottom, so we get negative 5 pi 6. So negative 5 pi 6 is the same thing as negative 150 degrees. It's just that we had to multiply by either pi radians over 180 degrees or vice versa. Now you'll notice that when we multiplied by pi radians over 180 degrees, we did so because this says, well, that's how you go from degrees to radians, but also because what we wanted to have happen was our degrees to cancel out. We wanted to get radians left over. And so the convenient way to remember this is, kind of like in this next example, it says, let's take 9 pi fourths. And what I want to do is I want to convert this into degrees and talk about its feasibility. What we're going to do is we're going to say, well, I noticed that the pi on top here, that's kind of like, this is like our radians. And so what we're going to do is we're going to multiply, since I want to go to degrees here, by 180 degrees over pi, and I'm going to write radians here. And this is in radians as well. And so our radians cancel out, and what we get left with is something that's in degrees. So let's go ahead and reduce where we can. I do see that 4 and 180, it's a good thing to know that 4 goes into itself, of course, one time, but 4 goes into 180, that's 4 45 degree angles there. And so as we multiply this straight across here, also our pi's cancel out, we get 940 times 45 here, and 9 times 45 degrees. 2 45s makes a 90, so I'd say like that's 2 45s, that's a 90 plus a 90 plus a 90, okay, plus another 90 plus another 45. So I guess this is kind of like 9 times 45. This would be a 405 degree angle here. We could check this out on a calculator here. But essentially, when you look at 9 pi fourths, that's like saying, recall that our pi fourths, a pi fourth rotation is a 45 degree angle. When you're seeing 9 pi fourths, all we're really saying is that you're taking 9 times a pi fourths rotation, or in other words, a 9 times a 45 degree rotation. So good to know for right now that basically you can either multiply by pi radians over 180 degrees or 180 degrees over pi radians, depending upon whether you want to go from degrees to radians or radians to degrees. Cheers.